So, welcome dear students once again to the NPTEL module on handling large scale unit level data with Stata. So, Stata is the software, statistical software, going to use it from the next week onwards, and some background will be also giving on it. But now in the week number 2, lecture number 8, we are discussing sample size. In the last lecture I was discussing the distribution, especially on sample survey types, basically sample type, probability sampling and non probability sampling, and where even sample size really matters. Even if we follow multi-stage sampling technique, we do require the correct sample size. In both the cases, though the non probability sampling design requires little less the size, because it is not going to generalize the population, it is very qualitative, it is quite pointed, but still that requires sample size. In both the case, sample size really matters. So, let us have a look at the sample design and a pictorial format of sample and population, where we are going to draw it. It may be the case that here in this particular picture, we have information about population here. Here we are saying some random samples are taken if you are adopting a probability structure, subject to the case that if population is homogeneously distributed, and if it is not homogeneous, then it gets little complicated. Now, it matters then homogeneous. If it is not homogeneous, then why and what kind of features are there which guarantees non-homogeneous? It may be the case that the data contains more distributional issues, it may contain more standard deviation, different standard deviation from one group to another group within the subsample of the entire population. If the variations are there, then the entire population is not homogeneous. So, therefore, the sample is designed accordingly, or the sample frame is designed accordingly. And here we are saying, first of all we derive certain sample, and then we check their details. The population mean, that is generally notated as mu, then population standard deviation, as I said, generally noted as sigma, and population proportion, if it is information there, we generally represent with pi, whereas if the same representative parameters are taken, actually representative discussions are made in the sample, we say x bar for sample mean, whereas mu for population mean, small s for sample standard deviation, whereas in case of population it is sigma, and in case of population sample proportion it is p, okay, whereas in case of population proportion it is in fact pi. So, these parameters, these indicators, in case of population we say parameter, whereas in case of sample we say statistics. So, there are two way of distincting these indicators. So, in case of sample these indicators are called statistic, and in case of population these are called parameters. So, I was just discussing from the beginning that population, its features are explained through mu, standard deviation or proportion, and accordingly we derive sample. We have already discussed sample type in our previous lecture. Now, let us proceed to understand the common questions we generally deal while discussing on the issues of sample size. So, first and the most important question strikes to the researcher is how large a sample size do I need. So, a survey designed to find out the proportion of something, or is designed to find a sample mean, is very important so far as the size is concerned. To get the answer for the sample size, the researcher asks certain questions like, how accurately do you need the answer regarding defining the how big the sample size I need. So, how accurately this is defined? and what level of confidence do you intend to use. Suppose I have collected some sample size, whether it is confident, I mean whether it is meeting the confidence interval. I mean confidence actually indicates the error, chances of error. Okay, if the confidence level is 95 or 90% or 99%, usually these three benchmarks are given, and accordingly confidence tables are there, okay, or errors are there. I mean reverse the confidence is nothing but errors. Okay. So, errors are indicated by alpha in our notation. Okay. So, now we are not discussing that in detail, but confidence usually bracketed in 3, that is 90%, 95% and 99%. Accordingly, errors are 1%, 5% or 10%. But that does not mean it is these are the 3 possibilities of error, there are n number of possibility of error. Even we can define 3% of error, we can define 2% of error, 9% error, any number is actually possible. Usually more than 10% error in any framework is not suggested, is not good, because if you do experiment or you do any kind of testing, your error is more than 10%. So, it may not actually meet the requirement, okay, may not solve the purpose, the results might be erroneous. So, then third indicator of understanding the sample size is what is your current estimate of the proportion of students who support proportion of students. In our case here we are taking the example of UNC students who support gay marriage. Now, we have an example, and we will discuss that in a short while with that example in our slide, that what proportion is actually important. So, in a sampling analysis we will come across these following questions. They are: what should be the size of the sample, how large or small should it be, if the sample size is too small will it serve to achieve the objectives, or else if it is too large then does it incur unnecessary cost or waste our resources. And the sample size or the sample must be an optimum size. So, optimum should meet those indicators we started discussing. I will discuss correctly whether that is actually meeting those indicators or not in our next slide. But now we are discussing the number of items to be selected from the universe is basically called sample, and that constitute our sample, and the number of individuals from whom we obtain the required information is actually called sample size. Usually sample size denoted with small n, whereas the population size is denoted with capital N. So, these are the indicator we will be using number of times. So, if our sample size result differently or inappropriately to the population to the population, our results might be misleading, and that can be presented with type 1 error and type 2 error. I think you know type 1 error and type 2 error. Sometimes we indicate, we indicate with alpha and beta notation for type 1 and type 2 error respectively. And these are like for example, you have selected a sample, but your result gives wrong result, your result gives wrong information. So, rejecting a null hypothesis when it is actually true is actually called type 1 error. In reverse, accepting a null hypothesis when it is actually false is called type 2 error. Okay. So, rejecting a null hypothesis when it is actually false, rejecting a null hypothesis when it is actually true. Okay. Actually you have taken certain sample, from a sample you tested that tested against the population. Your population suggests that something is right, but your sample said it is not right. So, you are actually rejecting based on sample. Okay. For example, in a consignment some packets are being transported from one place to another place. The excise officer just checked in between what exact content you are taking. Okay. Or even in the, suppose in a simple example like in the manufacturing unit for beverages, cold drinks beverages, the content, different contents are there, like chemical components are there, some percentages are allowed. Now, if they just simply test whether it is harmful, whether your chemical composition is going to be harmful for body or not, and some of the samples they collected, if those samples are actually erroneous, okay. Unfortunately, those samples are erroneous are actually picked off. Based on that, what you said, your entire package is bad, okay, and these are not good, not suggested for further manufacturing. So, based on sample you simply rejected. So, this is I mean it may be the case that these 3-4 indicators are bad, but others are true. Okay, but your entire manufacturing entire basket was true, but you have rejected the basket based on a sample. So, so rejecting the null hypothesis when is actually true is called type 1 error. Similarly, we can follow type 2 error. We will discuss many times in our success, I mean in our next couple of modules, couple of slides in our next, maybe next to next schedule. Okay. Then what is here discussed regarding population and sample. Here we say that will the sample be representative of the population, will the sample be accurate enough, whatever you selected from this picture, like some portion are selected, these are based on our sampling design we have already discussed. Some right sampling techniques may be applied to define whether these are representative or these are accurate enough. Now, in order to discuss that, sample size really matters. Without sample size we may not even discuss about whether these are accurate or not. So, these are our approaches to decide which sample size we should select. Now, then as I discussed already, what do you mean by optimum sample? What features it must fulfill? It fulfills there must be efficiency, representativeness, reliability and flexibility. Okay. If these 4 indicators are fulfilled, we have a dedicated lecture on this to understand the reliability of the data, and also we will understand representativeness of the data. So, but the level of accuracy that we desire for our research is an important determinant of sample size. Qualitative research or the question of sample size is in case of qualitative research, the sample size is less important. It is important to note that your qualitative variables must be different and must be complete. So, now in this slide we are discussing when your sample size increases, sampling error in the sampling format or design is going to be lesser. So, it is negatively related. Similarly, when the sample size increases, your confidence level is expected to be higher. Okay, we will discuss with further examples when regarding sample size in this particular lecture. What about errors associated with sampling? What do you mean by sampling error? Sampling error refers to the difference between sample statistics used to estimate a population parameter and the actual but unknown value of parameter, as I already discussed. So, sample error basically measures the gap between sample statistics and population parameters. Increasing the sample size will reduce this type of error. We have already discussed. The objective underlying any research project is to maximize accuracy by minimizing the total error. When the error is lesser, we can able to maximize our accuracy. So, the total sample error is basically derived by adding sampling error and non-sampling error. So, here the potential source of errors are here given. Usually there are some reasons behind sampling error and non-sampling error. Sampling error is resulted because the sample is not representing the whole population, whereas non-sampling error sometimes due to poor sampling method, questionnaire or measurement error or behavioral aspects. A certain behavioral aspect actually certain behavioral aspect do not give the right indicators to the surveyor. So, in a nutshell, sample error caused by the act of taking the sample, it occurs when probability sampling method is used to select a sample, this sample is not representative of the population concerned. We have followed a probability method, but actually it is not representing correctly to the population, then sample error occurs. Sampling error is also called error variance, because there are much variance from one sample to another sample. If you have taken one sample from the same population, you have taken once again another set of sample from the same population, another set of samples from the same population, error variance is expected to be higher. When the variance is much higher, this is also one indicator of sample error. Sampling errors are also those errors which arise on account of sampling, and they generally happen to be random variations in the sample estimates around the true population values. The magnitude of the sampling error depends on the nature of the universe, and more the homogeneous the universe, less the error, as I already discussed. Sample error is inversely related to the size, we have already discussed. Sample size we have discussed. Sampling error decreases as the size increases and vice versa. Sampling error can be predicted, calculated and accounted through several measures. Like confidence interval, we will discuss those indicators to discuss the sampling error, where size also matters. Standard error, one indicator is confidence interval. Standard error, actually standard deviation of the sampling distribution is called standard error. Coefficient of variation, then p values, probability value of the sampling distribution is very important. This gives the decision factor for the researchers at what p values we are going to stick. We will clarify this in our module. So, in this picture this indicates that population here in the larger circle, then sampling frame is made, then the exact sample group is defined with a smaller sample. Within that, once even the sample is defined where to take the sample, the response may not be entirely the sample units, there might be less responses. So, therefore, responses is actually figured on the at the center, okay, which is usually the less units. So, sampling error, as I said, it might be due to frame error. So, therefore, while we make a frame might be erroneous. Chance error, response error, and if we add measurement error or the non-sampling error to the sampling error, we get the total error. Once we add other indicators, we will get the total error. So, then what do you mean by non-sample error? Non-sample error is as against the sample error which may creep in during the process of collecting actual information. So, in the process of collection is very important. Such error occur in all surveys when whether it is census or it is sample. There is no way to measure sampling errors. Result from some imperfect aspects of the research design, such as mistakes in sample selection, sampling frame or non-responses are important. Non-sampling error can occur at every stage of planning and execution of the census or survey, such as faulty definition, improper training methods, defective methods of data collection, incomplete coverage or non-response, improper or ambiguous questionnaire, lack of monitoring and supervision of primary staff, errors during tabulation, errors in data processing and its operation, improper interpretation during the analysis and report writing. These are all possible non-sampling errors. So, therefore, types of non-sampling error are of two types. One is non-response error and response or data error. So, what do you mean by non-response error? Non-response error are those where units are selected as part of the sampling procedure which do not respond in whole or part. So, and when obtained the sample differs from the original selected sample. When there are differences, then this also occurs. Responses can occur in two ways. One is non-contact or refusal. Non-contact errors can be reduced by careful examination of the selected sample, whereas refusal rates could be actually brought down to a manageable level by giving training to the interviewer and continuous monitoring the process of investigation. So, what do you mean by then response or data error? It is usually a systematic bias which occurs during the data collection or analysis or interpretation stage, and that too when the respondents give inadequate answers also that mislead the information, and sometimes these actually are actually misrecorded or misanalyzed, are called data related error. So, data error again classified into majorly of three types: researcher error, interviewer error, or respondent error. So, what do you mean by then researcher's error? Researcher's error may be mentioned as population specification error, when a researcher selects inappropriate population from which we obtain the data. So, these are called population specification is important. Similarly, sample frame error, we have already discussed that. Sample frame occurs when the wrong subsample is actually used to select a particular sample. Out of the total universe, you have actually bracketed into different subsamples, but subsamples may not be actually perfectly fit. Okay. You wanted to study the health related information for and they are gender divide, but actually you haven't particularly categorized into gender differences. You have simply randomly selected health issues from the population. So, gender issues are not correctly represented. So, those called sample frame error. Surrogate information error, information is obtained from substitutes rather than original sample. Okay. For example, past behavior, if you consider attitudes of the person, beliefs are generally creating errors. Similarly, measurement error, difference between information generated and the information wanted by the researcher. If the information required is not perfectly matched with the collected, then there are measurement errors. Similarly, experiment error, when we control over the exogenous variable which is not possible, we are trying to control but not possible, may actually lead to an inclusion of bias in the experiment. So, there are lots of actually bias in the experimental design create error. So, interviewer error, respondent selection error, selection of respondent is if it is wrong, questioning error, questions there are problem with the questions, recording error, cheating error, like data is actually compromised for the sake of convenience to save time. This is usually the case in the field survey, okay, and to minimize money also that creates some kind of error. Respondent error is of another error which are due to inability and due to unwillingness. And now what are the criteria of determining sample size? So, the criteria broadly, after discussing the sample error and understanding the sample size and its framework, why sample size is really important. So, let us understand the criteria of the sample size. So, the criteria requires understanding the nature of universe, the entire population of our targeted survey, number of classes proposed within the subgroup, how it is defined, and nature of universe. Particularly, we are interested broadly here to know whether the universe is actually available in a homogeneous format or in a heterogeneous format. Suppose it is homogeneously distributed, the universe is homogeneously distributed, then as I mentioned from the beginning of our sampling design that we require less sample, because less sample can represent your entire universe when it is homogeneous. But if it is heterogeneous, there are huge variance from person to person or group to group within the universe, then you are supposed to take more sample size, because you are supposed to divide more sample groups or subgroups. Okay. So, when the universe is heterogeneous, you are supposed to break or supposed to collect more sample size, that is the standard rule because of dispersion factor. What about about sample size in case of nature of the study? Nature of study is important, whether your nature of study is very intensive, very core, then you specifically require qualitative information. So, in that case you need not cover more sample size, you may simply cover small sample size. So, the standard rule is to stick to a small sample size and study intensively. If it is a general survey, obviously it requires large sample. Okay. then so far as the number of classes proposed, number of subgroup is important. Subgroup is there if and only if you have I mean you have clear subgroups. If the subgroups are defined and subgroups are lesser, there are less number of subgroups, obviously you are supposed to collect less size, sample size. If more subgroups are there, then large sample is required, and more subgroups are defined, as I mentioned, it is due to variability or dispersion factor as well. Now, other indicators like standard of accuracy or acceptability related to confidence level. If the confidence level is there higher, higher, then to make your confidence level higher, you are supposed to collect more sample size. Okay. Then type of sampling, what kind of sampling type you are adopting, availability of finance and other considerations. Let us explain some of those. Regarding standard of accuracy and acceptable confidence level or accuracy, either it will be low or high. If you wanted to lead with a low level of confidence, then you need not require more sample size. Sample size is low in that case. Whereas you need to make better confidence among your researchers or in your study, that nobody can reject your answer or result. In that case, you are supposed to take large sample. For doubling the accuracy for a fixed significance level, the sample size has to be increased fourfold. It is a standard rule defined by statistician. To double your accuracy, you are supposed to fourfold, 4 times increase your sample size. Then regarding type of sampling, you are supposed to follow a small random sample is apt to be much superior to larger but badly selected sample. So, type of sampling is very important, small versus large. Small is may be very apt also, depending upon again your universe or genesis. Okay. And regarding the availability of finance, this is important because this result in cost to the surveyor. So, cost estimates is very important from the beginning, and so availability of finance is very important in the sampling framework. What are the other indicators, other restrictions or considerations, like nature of units you are collecting, size of population, size of questionnaire, availability of trained investigator. If trained investigators are there, with the less sample information, they can able to estimate a right result. The condition under which the sample is being conducted, the time also important, time of survey is also important to deal with this aspect. Now, those who are interested more in understanding the sample size, I think so far in my knowledge till the date, every researcher actually is interested in understanding sample size. They are often confused what sample size I should take. So, some of the indicators we already discussed. Now, accuracy and confidence level is very important. So, as I already said, accuracy level may be 95%, maybe 90%, maybe 99%. These are all important. So, margin error we will discuss its calculation. Margin error usually decided at 5% level. Is a common choice. The error is acceptable. Okay, error is acceptable at 5%, and if you know your population, if you know your population in total, then based on this website, if you click on this link selectstatistics.co.uk and simply click there, click this website, and you will be directed to have these indicators, to fill off these indicators, like what is your margin error, let us set 5% for it, what is your confidence level, usually 95% for it, and what is the size. If it is 1 lakh, you can write 1 lakh there. If it is 50,000, you enter 50,000 there. For our answer, we are specifying here at 10,000. Now, what is the proportion of your sample to be included? What is your sample proportion? Let it be. What do you believe the likely sample proportion to be? Usually it is 30%. Usually it is 50%. Okay, not 30%. Usually is 50%. 50% accept 50% of the population have the chances of inclusion in your sample. So, what do you mean by that? We are actually not distinguishing population. Each person has equal probability of selection by half. 0.5 is the probability of inclusion in the sample. Okay. So, this is 50% means half. So, if you enter that, it suggests a sample size called 383. We will discuss some formula, Cochrane's formula, even even there are certain other indicators of including like as I mentioned, we have some alternative scenario also. I will come to it, come to the discussion correctly, that how much to be included. And how we are actually calculating, we will go by the exact formula. Okay, the formula to be derived here and discussed. Now, as we all know that sample size, margin error, if it is 2%, then how much sample size to be there? If it is 3% sample size, look at this. If margin error is higher, you need not include more sample size. Margin error is more, sample size reduce. Or if sample size reduce, marginal error actually increases. Sample size again reduce, marginal error actually increases. If it is 384 or 383 here, marginal error is actually 5%. Okay, this is indicated in this diagram. And sample size is 96, marginal error is 10%. Given other indicators to be intact. Okay. So, the distribution is defined accordingly. We will discuss this normal distribution with different different ways of whether it is symmetric or non-symmetric in detail in our sample size determination. And what I just said is actually indicated in this particular box. Okay, or like sample size with marginal error, then margin error with sample size, confidence interval and sample size, population size and sample size, population proportion and sample size. You can have a comparison. This and this you can have a comparison, you will understand correctly. So, in the next class we will discuss further on it, and we will carry forward the sample size discussion to the next class, and we will discuss these aspects like which approaches are important in understanding or determining the exact sample size with equations. Okay, with the exact theory and their calculation with certain formula we will discuss in our next class. Okay. So, with this let me stop here. So, I will catch you up in the next class. See you.